let's talk about resonant frequencies. All things are going to, resonant frequency is a frequency, it's a sort of a natural frequency at which things will vibrate. Now, there's different circumstances which affect what the resonant frequency is, and we'll talk about that in just a moment. But first off, just a quick example. I pound on my desk, the vibration is going to move through that desk at a certain rate. And I can put different stuff on the desk, it's called dampening, or I can take stuff off, which is the opposite of dampening, undampening. And the vibration, the rate is going to change some. But the vibration goes through it at a certain rate. Now we can, violin string, another example, guitar string, when you pluck it, a particular string, you hear a note. You don't hear a combination of notes, even though there's a combination of frequencies there because all instruments sound different, and but that's as close as you're going to get to sort of a pure note other than computer generated. So I can change the resonant frequency of that string by tightening it some. I go up to the knobs at the top and I tighten it, and as it tightens the string, it changes that resonant frequency. Now I can demonstrate relatively easily with a rubber band here. So I'm just going to play the rubber band. There's a certain frequency there. Now if I stretch the rubber band, as I make it tighter, I increase that frequency. And by consequence, as I increase the frequency, I increase the pitch. But a resonant frequency happens at a natural, it deals with when you add an amplitude to it from a physics point of view. You basically, when you pluck it, you displace it from equilibrium. You add an amplitude that the wave is going to move down the medium, whether it's a string or anything like that. It's going to move down it and then back and forth. Now, what happens when the wave moves down it and hits the boundary? And that's a different video, but I at least wanted to cover the basics of a resonant frequency.